My name is Zenobia Godschalk. I'm the SVP of Communications here at Hedera, and I am joined by our two co-founders, Mance, Harmon, and Leemon, Baird. We are celebrating, we are in the midst of Earth Week this week. So for those who haven't seen it, I would encourage you to visit our YouTube channel. There are a number of dApps that we have spoken with this week and will continue to talk to throughout the week that are sharing just how green the Hedera network is and how they're able to use it not only to make their dApps more energy efficient, but to also build applications that are really contributing to the future of our world and contributing to make it a better place. There is a report out from Power Transition that talks about, in some very tangible numbers, the differences in energy consumption of Hedera versus other networks. I would also encourage folks to look at those. And each of the videos should have links to the applications and what they're doing. So welcome to this Earth Week edition of our town hall, and we can go ahead and get started. Leemon, we are going to jump in, and we try to tackle as many things as we can on these town halls. So this month there were a number of questions from the community on the transfer of tokens from the founders' accounts and whether that involved selling and whether that occurs when the price of HBAR is down.
Oh, good question. No selling when the price is substantially down. So the selling happens according to a plan. The plan is detailed. It's published on our website. There's an FAQ. I think maybe we'll have a link to it put in the chat. But the plan says no selling when it's down. And there's lots of details, lots of constraints. Don't sell too much if the volume's low, all that stuff. So that is in an FAQ, frequently asked questions. It's published on our website. And of course, you talked about transfers. What you see are transfers from accounts. But when you sell coins, what you usually do is you transfer a bunch to an exchange or a third party. And then throughout the day, you can be selling from that, and you can sell it for several days. And then when the balance gets low a few days later, then you transfer another tranche. So the transfers and the sales aren't quite the same thing. If sales stop for a day or two, you might not see it just looking at the transfers. If the sales stop for weeks, you would see it, but not if it's just briefly. But the transfers and the sales are slightly different because of the way you normally sell. And all of that is regulated by the plan. It was established last October, and it's in the FAQ. So go ahead and look at that if you're curious about all the details, all the numbers.
Great, thank you, Leemon. And I will just note that the FAQ has been posted in the chat, so feel free to take a look at that afterwards for those who want more in-depth details. All right, Mance, in the spirit of transparency and community, we have a request that can at least one question answered during each town hall be that which is most popular as determined by a democratic vote or a weighted vote. It seems like the questions which are answered are selected solely by Hedera, not by the community, which feels a bit scripted and unauthentic. Could you vote, close it, and ahead of the town hall, maybe using the HBAR community telegram, capture votes for questions for these town halls?
Sorry, I'm now off mute. No, look, I completely appreciate the question and understand why it's being asked. It is difficult, and it's difficult for some unexpected reasons. And let me try to explain that. There are certain constraints that we just have for legal reasons or regulatory reasons. So for example, we can't make any kind of predictions. There can be no forward-looking statements that we make in any kind of public context like here, the town hall. Also, we don't talk about token price. We get a lot of questions about the HBAR and about token price and predictions and blah, 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 right? And we don't talk about token price. Also, there are questions that come in that are great questions, but those questions are best answered with the appropriate timing. The questions may be related to ongoing activities or projects, and it's just the work that is being performed isn't yet completed, and therefore it's not appropriate to talk about something that's sort of half-baked. So we don't. We take those questions and we move them forward to the next month. We keep a spreadsheet of all the questions that come in, and there are those questions. We just say when going through these, that looks like a good question to answer next month. There are those category of questions. We don't talk about our competitors. We get a lot of questions about competitors of various types of questions and various flavors. Many questions have already been answered. As Zenobia talked about earlier, the community is growing. There are a lot of new people in the community, and they naturally are asking obvious questions. And we've been doing this now for a year, I think, maybe longer. And so there is just a lot of questions that we've already touched on. And so we don't go back and try to address them again. Sometimes we do, but we try to make it a policy not to. And then also there are questions that maybe are asked about those that we're working with. And we have to protect the privacy of our partners until they are ready to announce whatever it is that they're working on. So, it's not as simple and straightforward as you might imagine it being. And we have these constraints on us. So we're certainly open to something, but it's, I can't envision an approach that addresses these constraints in a meaningful way. And that's why we do what we do.
Thank you, Mance. And, that's not to say we don't try to take things head on. We absolutely do. And so in that spirit, Leemon, this next one is for you. There is a public critique of Hedera that the Hedera Hashgraph system only provides fairness of ordering for consensus messages, not for transactions within a message. It goes on to say any batch node transactions can choose which one of those messages came first and which one came last, any node batching those transactions. And they can use this small power they have, for instance, to front run orders, for example, in a stock exchange. Can you share with us, is there any truth to the statement? Is it moot because all transactions are batched into one event that's gossiped out? How would this play out, for example, in fair ordering of bids and asks in a stock exchange?
Oh, great question. So there's several different misconceptions here, and it's not how it works. So first of all, when you want to submit a transaction, you give it to a node, and that node will then send it on to the whole network. It gets gossiped out. If you give it to the node Alice, then Alice will send it to the network. And if several people give Alice transactions, she will send them out to the network, and they will end up in consensus order in the order that Alice sent them out. Now, if you send transactions to Bob, his will be sent out in some order, and they will end up in consensus order in the order he sent them out. It has nothing to do with whether they're all in one event or they're all broken up into individual events. That has nothing to do with it. It will always be in the order he sends them out. So talking about bundling into messages or bundling into events is completely irrelevant. It has no effect on this. It's simply that if you send your transactions to Alice, the order in which she sends them out, hers, the ones sent out by her, will all be in the order she sends them out. And the same is true for Bob. The consensus is in, well, how do Alice's and Bob's interleave? Do they interleave like this, or is it like this, or is it like this, or is it, sort of like this? There's lots of different ways that they could interleave. That's what the community is figuring out. But if you just look at one node, they'll end up in consensus order in the order in which that node sent them out. So it has nothing to do with messages or bundling or events or whatever. I've seen this misconception. It's just, that's not how it works. So then the second question is, well, is it going to be fair? Is the community going to end up putting them in this order in a fair way? Well, Alice put them in an order in a fair way. And of course, there's three different kinds of fairness here. And then there's talk about front running, which is maybe a fourth kind of fairness. And then, life's not fair. That's a fifth kind of fairness. So let's talk about the different fairnesses. What we would like, ideally, is to put them in the order in which the network received them. The New York Stock Exchange puts things in the order that they come to its one single computer. We want our ledger to act like that. But since we're multiple computers, what would you mean by the time at which it reached the network? Do you mean the time at which it reached the very first node? That wouldn't make any sense. Maybe that node never forwarded it on. And then a year from now, that node tells you, hey, I had one I forgot to tell you about. Would you give it credit for having happened a year earlier? Well, you can't do that. You've already made decisions. You can't undo them. So it wouldn't make sense to say you have reached the network when you reach the first node. Okay, how about it when it reaches the last node, when it's reached the entire network? Would that be the fair time to say that's when it reached the network? Well, not really, because what if that node's turned off? Then the whole network would have to freeze. If it's turned off for a year, the whole network would freeze for a year before we ever knew what order things are in. You can't really do that. If you're going to treat the network as virtually being like the single computer at the New York Stock Exchange, then the most rational thing, the most fair thing is to say you have reached the network when you've reached the majority of the nodes. When you reach just over half of the nodes or half the nodes, you have now reached the network. And because of the gossip protocol, it's very hard for an attacker to stop. Once you're in the network at all and spreading in gossip, you're going to spread out to everybody very fast. And so it can be very hard for an attacker at that point to stop you from reaching half the network once you've reached a few of the nodes. So fairness of timestamps come from that. And so if you care about fairness of timestamps, this is clearly what you would mean by fairness of timestamps. But there's other kinds of fairness. What about the fairness of the ordering? Well, it would seem like the most fair way to put things in order is to do it by the timestamp. Why would we put them into an order different from the order at which we received them? You know, the New York Stock Exchange has a single computer. It puts transactions, asks, and bids into order by the order it received them. It would be unfair to do a different order. Then there's just, is life fair? Turns out people who live right next to the New York Stock Exchange can get their bids and asks in milliseconds faster than someone who lives far away. People have spent like $100 million drilling a hole through a mountain just to get to the New York Stock Exchange a few milliseconds faster. So you could say, well, it's unfair that I live far away, so mine gets in later. Yeah, okay, life is unfair. That kind of unfairness isn't the New York Stock Exchange's fault. It isn't their algorithm's fault. It's just the fact that the world is distributed. And in that sense, of course, we have the same problem. If somebody shuts down your connection to the internet, you just won't be able to bid that day. And that's unfair. Life is unfair. But if you haven't access to the internet at all, we do have a fairness of access that in many ways is better than what you would get with the New York Stock Exchange. And here's why. Everybody might live near a different node, but as long as you give your message to your node, it'll then spread exponentially fast through the network. And so in that sense, people around the world all get to live right next door to us. Whereas in the New York Stock Exchange, you have to live in New York to live right next door to the server. So fairness of access is better. Furthermore, you can choose which node you're submitting to. So if you know a node is nice and honest and always gets theirs out quickly, then you can choose that one. So if Alice always sends hers out, when you send it to her, you see it goes out right away, you can always send it to Alice. And if Bob tends to be kind of slow and sometimes doesn't send it at all, you can just ignore Bob. And so you get to choose. So you have fairness of access in that way. And then in addition, you have fairness of access in the sense that if you really wanted to get out fast, you can send it to lots of nodes. And then it truly will reach the majority of the network a little bit faster. Just a second faster or a fraction of a second, I don't know, but it will get there faster. And so that is a way that you can manually ensure that it gets out faster. And you pay a little bit more. If you send it to n nodes, you're not paying n times as much. You only pay once for the service, but the node fee you pay and the transaction fee, or the network fee, you pay a little bit more. So you will pay n times as much on that part of the fee, because you're making us do more work. But that would ensure that it gets out. So for fairness of access, it's kind of the best that a ledger could ever have. You have access to it, and it's definitely better than a single server, like the New York Stock Exchange, where access is only good for people right next to it. And then there's the question of, well, that was it, right? Fairness of time, fairness of ordering, fairness of access, and then just, kind of, is life fair? And then there was the question about front running. If you want to be able to avoid front running, even with the New York Stock Exchange, if a router along the route is seeing your message, it might put in another message reacting to that. If you want to stop front running in a public ledger where the whole world can see what's happening on every node and every node is untrusted individually, then what you have to do is set up some kind of system with rounds. This is the way that the world has to work. And so what you would do is you'd use HCS, the consensus service, to create an AppNet for your auction or for your stock market. And you would say, okay, every 5 seconds, we'll start a new round. So for the first 5 seconds, everybody can put in their bid or ask, but you only put in a hash of it. So nobody can read it. So nobody can read it and then front run you. And then at the end of those 5 seconds, it's now too late for anybody else to put in any more hashes. And we know when the 5 seconds ends because there's a timestamp, a consensus timestamp that was fair on every transaction. So we know when the time limit is. And then in the next 5 seconds, you can send in your actual bid or ask, and it only counts if its hash matches what you sent during the first 5 seconds. And that stops front running. And then there's various attacks on that and ways of stopping the attacks, and there's a whole literature about that. But that's the way to get fairness in a public ledger. Sorry, not fairness, the way to stop front running in a public ledger. And every ledger is the same in that respect, except if the ledger is really fast, that helps a lot. Because by going to rounds, you're going to be slowing yourself down. So you really want a ledger like Hedera that's very, very fast. And that gets consensus very fast. Also, if you're going to do this thing with the times, you really want finality. So finality and speed are very, very important for that. But other than that, it's just something you're building above the ledger, and it doesn't matter what ledger you're dealing with. So it's a big question. We have a blog that goes through fairness in a lot more detail and has pictures. The pictures help a lot. And has that blog been? No. So maybe we could put a link into the chat that would give you the blog post on fairness. So that was a long answer. We've talked about it before, but you know, not everybody sees everything. And I think it's an important issue because Hedera is really good at fairness, more so than blockchains and other things that we could talk about. And the paper talks about that too. So anyway, good question. Thank you.
Thank you, Leemon. And yes, the link to the blog is now in the chat for those who want to read more details. One more question, Leemon, on a technical level, what would happen if some of the mainnet nodes decided against a software update and just continued to use the previous consensus rules?
Oh, they fall off. It's just automatic. There isn't even a mechanism to do it. It's just inherent in the algorithm itself. What we do is every round, every node has to digitally sign the hash at the root of the Merkle tree of the entire state. So, you know, about once a second, every single node is digitally signing. Here's what I think every single account in your system has, and what every state of the smart contract is, and what all your files are, and what the history of your HCS is for the last few minutes. Every second we're doing that. And then each node collects signatures from others. And if someone didn't install the software upgrade, they get a different state, their signature doesn't match, everybody else just discards their signature. It just looks like a bad signature, so it just gets discarded. So they basically have no effect. And if they tried to send their information to a mirror node, the mirror node will reject it because their signature doesn't match everybody else's signatures. And so they instantly get kicked off the network, in a sense, in a fraction of a second. It's wonderful. So that's what happens if you don't update the software. But we're building it so that it'll be automated, so you won't even have to do anything to update the software. It just happens. But if you intervened and prevented it from happening, you would just be automatically kicked off in a second, and it just is inherent in the algorithm.
All right. Thank you, Leemon. Mance, here's one for you to tackle. At your current cash flow burn rate, will the transaction revenue pick up fast enough to cover expenses before you need to raise more funding through coin sales? So
what we are doing is tracking very nicely, very closely to the original plan, both in terms of cash burn as well as TPS growth. So we're very happy with both of those metrics. Having said that, there are ways in which the community can benefit from our having an additional level of cash, more cash. And I'm not prepared to go into all the details of what that might look like, except to just sort of directly address the question and say that it's very likely that we will have another round of financing to address those needs. And stay tuned. There'll be more details coming.
All right. Leemon, this next one has to do with NFTs, which are all everybody is talking about. How do you support fractional NFTs, for example, for crowdfunding?
Yes. So NFT is, you have a bottle of wine, you have a different serial number on each bottle, and you have an NFT for each bottle. But what if you wanted to actually divide the bottle into pieces and sell shares of that one bottle? Yeah. So if you build NFTs on top of our HTS, then what you end up having is each bottle counts as a token type. It's like its own ERC20. So our equivalent of a 721, an ERC 721, is like a bunch of ERC20s, which means that each of the serial numbers can be subdivided into 100 million pieces. That's kind of cool. Actually, more than that, billions or trillions or whatever, quadrillions, lots of pieces if you want to. Or you can do a traditional NFT and not let it be divisible. And so when you create it, you have the choice. You can make it be completely divisible or not divisible at all. You have that power. And that's if you build your NFTs on top of our HTS. You could build your NFTs on top of our HCS, in which case you can do anything you want. If you're using our consensus service to build an AppNet, you can do anything you want. And certainly you could do fractional. So either way, when you build NFTs on us, you get the power and the speed of Hedera, of the native token, but you have the power for fractionalization. And that's a pretty powerful concept that most NFTs don't support. And not all NFTs need them, but it's a useful feature.
All right, thanks, Leemon. Mance, transaction volumes on the network have been steadily rising throughout the year, but daily volumes suddenly halved in early April. And, this is per Dragonglass. Can you explain why? And then, I would note the volumes have gone up since then.
Yeah. Well, so first off, and many of you already know this, you don't need a license to build on top of Hedera. You don't even have to tell us that you're doing so. So there are a lot of projects that we're unaware of that are using the network. In many cases, we are aware of specific projects that are being built, but it's increasingly the case that we're not. That's a really good thing, right? It's a good thing that people are electing to use the platform without ever having talked to us or us being involved in that decision process at all. So companies and organizations are building and deploying on the platform, and only after the fact do we become aware. And it's a great feeling to see it happen. When we get surprised by seeing projects, that's the way it should work. And that's happening on an increasing basis. We are aware of some projects, and we have been aware that some of the projects were going through various stages of testing that would drive TPS. So it's not entirely surprising to see, up and down volumes on TPS from our perspective, but increasingly we don't know what's going on the platform, and that's by design.
All right, thanks, Mance. Leemon, this one has actually popped up a few times. What is meant by controlled mutability to address legal and data compliance? We're hearing, isn't immutability an essential property of a DLT?
Oh, yes. So we are immutable in that sense, but we also have controlled mutability. So let me talk about what this all means. And I think I've talked about it before, but let's talk about it in more depth in here. Boy, I'm getting a lot of really good technical questions. I love this. So every ledger lets you have an account with coins in it, and you can hit more coins go in and your balance goes up, and then coins come out and your balance goes down. So the balance is mutable. It is changing over time. You have smart contracts, and you make calls to the smart contract, and the state of the smart contract is changing over time. So that's mutability of the state. But the history of everything that's gone in and out is immutable. No one can ever change the history. It is permanently recorded forever and cannot change. And the history of all the calls to the smart contract and the results is immutable. It is permanently recorded forever. We're the same way. So we have the control mutability. Your balances can change. The state of your smart contract can change. But the mirror nodes retain the history forever. And not only that, it's all chained together with hashes and digitally signed by the whole network. So it isn't just a chain of hashes that's protecting it. It's actually digital signatures from everyone in the network that is protecting it. And so these signatures are actually collected by the mirror nodes, and they won't even believe any information they receive until they get those signatures. And they store the signatures. And so they have the signatures, they have the entire history of everything that's happened. You could download the whole thing if a mirror node's willing to sell you their entire history or give you their entire history. And we have some third-party mirror nodes that have the entire history. I think there's also, there's now, I think, S3 buckets where you can also download it from. But the whole history is there. You can get it. It is immutable, and it's cryptographically guaranteed, and you can check it. What's mutable is the state of the network. And so every ledger has to have a mutable state. We have a mutable state. And the state is controlled in really nice ways. And so we have all sorts of cool features, like when you create a file, you can have a list of signatures where all of them have to sign to create the file, but only one of them has to sign to delete the file. You don't have to do it that way, but you can, which is great. You can use that for something like my driver's license. I and the DMV have to sign to put it in there, For privacy, I'm protected, but the DMV by itself can take it out, so it's a revocation service. And so you have that kind of controlled mutability. There is also the ability for the council to remove really, child pornography or really bad things in files and smart contracts. However, the council does not have the ability in the code to touch the accounts or the HTS tokens or the HCS topics and the messages flowing through them. There is no way to freeze an account. There is no way to take HBARs out of an account or to freeze a token or to take HBARs or tokens out of the token out of your account. There's no way to freeze a topic or to censor the messages flowing through it. The software completely disallows that. And you would take most of the council signing something to change this. This is kind of set in stone in the software itself, where they cannot censor and control these things. So that's what we mean. It sounds confusing when you say controlled mutability, but it's also immutable. And yes, we have controlled mutability and it's also immutable. So that's what we're talking about.
Thank you, Leemon, for explaining that. I know that's a lot to wrap your head around. I'm going to lob one more to you now. Does Hedera's no fork guarantee extend to after the Hashgraph patent expires? And if so, how does it?
Yeah, so this is cool. At the beginning, it was very important that we have a multi-pronged approach to stop forking. And over time, the patent part of that is becoming less and less needed because the other parts are becoming more and more important. So what we have is a council that is amazing. We have the majority now of our 39. The 20 makes up a majority of 39, and they're really big names. This council has turned out far better than you might have expected on day one. It's just amazing. And so it looks kind of hard to build a council like this. You look at other projects and it looks like it's difficult to get a council like this. They aren't just advisors, they're actually governing, and they're really big names. Brings a lot of trust. It would be hard to fork because the fork wouldn't have such a council. And I was just talking a second ago about the cryptographic proofs that the history is correct. It's not just showing that it's chains that chain together like you would with a history of a blockchain. It's actually showing that this particular council was signing off on it at each of those points. The digital signatures themselves are part of it. And so if there were a fork, no one could ever fool you into thinking that other fork is the real one because the signatures wouldn't be on that other fork. And so the technical ability here is really powerful. And that's what the state proofs that we have right now with our mirror nodes. And we'll even go further when we have state proofs for every query. And so we have these technical abilities, and then the updates themselves to the software and the updates to the address book that controls who is running a node. Those themselves are controlled by the network itself in a way that ensures that you couldn't really fork and fool people. If you ever tried to fork, everybody would know that it was a fork and that it wasn't the real one. So you could easily have software when we have the individual state proofs, you'll have software on your phone that every time you ask us, what's my balance? Or who owns this house, who owns this NFT, you'll be guaranteed that you're talking to the real network and not to a disgruntled node that used to be part of us, but now is part of a different network, or maybe is on part of both at the same time. You'll be guaranteed cryptographically that that's not happening because you'll essentially have signatures from our whole network agreeing. And so we have more and more over time, really powerful anti-forking guarantees. So the part of the patent is becoming much less important over time. So when it expires, who cares? These other ones are turning out to be really powerful.
All right, thank you, Leemon. The next one I'm going to tackle quickly because I know we are just flying through this hour. By simply comparing the fees of Visa and of HBAR transactions, is it fair to say that HBAR will use 10,000 or even a million, 10,000 times or 1,000,000% less energy than Visa? So the great thing is we are looking at this. We've obviously seen how the network is running, but we have a number of applications who are testing it in real life and are using it and have done some of those comparisons for themselves. So in the chat, we are going to post a report that's out from Power Transition this week that highlights the energy consumption of Hedera versus other DLTs and also compared to the Visa network. And I think you will see from there that we compare quite favorably. Okay, Leemon, how will Hashgraph scale when permissionless nodes are added and there are thousands of nodes which all need to have the complete history of every other node instead of just 39? Even with gossip being the fastest way to spread information, how can we know that latency won't be significantly compromised when many more nodes are added?
Okay, so when we have 10,000 nodes, we're going to have lots of shards. And the beautiful thing about a shard is that a node in one shard doesn't have to know the complete history of a node in another shard. And so you don't have to worry about that. It has to know its own history. And actually, the mainnet node in that shard only has to remember the history for the last few minutes. Technically, only the last few seconds, but we keep a minute or two just to be safe. It's the mirror nodes that keep the entire history forever. And so even the mainnet nodes in that shard don't have to keep it. It'll be the mirror nodes for that shard that have to keep the infinite history going back forever. And they can do so. And you can have a mirror node that mirrors all the shards if you want to keep all the histories, or you could set up separate mirror nodes. And so, only have some of the shards or one of the shards that you're remembering. And so you can set that up. And so, yeah, when we have 10,000 nodes, they all go across shards. Latency within a shard gets worse as you increase the number of nodes, but latency doesn't get worse when the number of shards increases. There's no penalty for having more and more shards. And so once you have filled up one shard, there's no more latency hit as you add tens or millions of more nodes because they just go into more shards. In fact, having more shards should help us with throughput and overall speed. So yes, that is not a problem. As for within a shard, you would expect it to be logarithmic scaling. So I was just talking to someone this week about that who even knew it was logarithmic, didn't understand really what logarithmic means. It means that when you go from 1,000 nodes to 1 billion nodes, does it take 1 billion times more time or 1 million times more time? No, it takes 3 times as long. Going from 1,000 nodes to 1 billion nodes only takes 3 times as long because it's logarithmic. That's the beauty of logarithmic curves. They just grow very slowly. So that's the technical answer.
Great. Thanks, Leemon. Mance, one for you. Do you hope there will be many projects by indie entrepreneurs with their own utility tokens based on Hedera?
Yes, simple answer. Yes. So, well, look, we care deeply about indie entrepreneurs. When we talk to our partners, it's because we need to. I assume that the question was, are you only focused on enterprise, or do you care about both enterprise and startups and indie entrepreneurs? When we talk to our users of the network and partners, it's because we want to understand what features need to be added to the platform. We aren't in the position, nor do we want to be, of pushing specific projects with select partners. If we know about a project and there's something that we can do to help support in terms of explaining our architecture or recommending design patterns, et cetera, that type of thing, then of course we want to do so. But it doesn't matter whether it's a Fortune 500 or an indie developer with an amazing project. We are in the business of creating the operating system and explaining how it works to those that want to use it. And it doesn't matter who you are. We want to be working with you to support your needs.
All right, thanks, Mance. Yes, we'd love to hear from you. I will say that chatting with some of the developers over the past few weeks, as we talked about their projects, I always hear great things about our developer advocate team. So I have to give them a shout out for being so responsive and so engaged, and just thank them for all the time that they take with everybody who's interested in Hedera. Leemon, could you use a DLT like Hashgraph to store digital information and files, just like Google Cloud, without the actual need for additional physical memory?
Sure. You can store all your files on it. We have a file system. We've had it from the beginning, a file service. We had it from the beginning. You can do that. And it's better than a cloud in that it's being stored on far more computers, lots of copies of it. And there's these guarantees that the whole world can see it and everybody will see the exact same vision of it. Now, you may not need everyone to see it. You might not need it to be stored on all that many computers. And so you're just paying for an extra service you don't need. And if you wanted privacy, you'd have to encrypt it anyway. And then you don't really care that everybody can see your ciphertext. That's not really a bonus. You're not really willing to pay for that. So what typically people will do is they will store files gigantic files in a cloud because it's stored on fewer computers and has easier privacy controls. And so that just makes sense. You'd store the bulk of your data in the cloud, and then you would store hashes of it in a ledger. And there you're paying for it to be stored a lot of different places and ensuring that the whole world can see it, and then it guarantees you're showing everyone the same data. And so typically people would do it splitting their data. You sort of have the data in the metadata, you put the metadata in the ledger in Hedera, and you put the giant data in a cloud where it's cheaper. But you could put it all in Hedera if you wanted to. And yeah, it can certainly do that.
All right. Mance, is Hedera on track versus our own KPIs for adding new council members?
Simple answer again, yes. Things did slow down a little bit in Q4 of last year, but this year's been fantastic. And so not making any forward-looking statements, but we're happy with where we are today.
Great. All right, Leemon, we know the throttled speed of Hedera is 10,000 TPS. Can you talk about how high the throughput can potentially get in a single shard when it's unthrottled? And after sharding is introduced, how high can the throughput of the network potentially be?
Great question. Boy, we're getting a lot of technical ones. I love it. So we right now throttle the network down to 10,000. You can only do 10,000 transactions per second. And our actual usage is 100th of that. So, we're using 1% of our capacity right now. And our usage is growing, and it's growing pretty rapidly. So it'll take a little while to get it to be 100 times as bigger than it is right now, but it will get there, I think. And I think it'll get far beyond there. I think we're gonna go far beyond 10,000. So there will be the demand. At the moment, though, a demand is, 100th of that, but we'll get there. Could we go faster? Well, sure. So in the lab, we've tried making changes to the software, then have seen it running at many tens of thousands of transactions per second. And that's with a Merkle tree. That's where every time you move something, your balance changes. It changes in a leaf of a Merkle tree, and we have to recalculate all the hashes in the Merkle tree so we can sign the top of it once a second. All of that was still running at many tens of thousands a second. So, it looks like that it ought to be possible to go much, much faster. But we haven't rolled it out. And the reason is, if you're going to make a change like that, then you want to test. Does it work with new features that we've just added and new features we're about to add that we're working on that we haven't even announced yet? Does it work well with those? Does it work well when someone falls off and has to reconnect and they're trying to catch up to a network that's moving faster? Does it work well there? Does it work well when you have to save the state to the disk periodically? Does it just work? You just want to try every possible scenario. Does it work well when we have 100 million accounts instead of 100,000 accounts? And we expect that to happen too. So, or entities at least. Especially with tokens. Tokens are great. So what we would want to do is to not just make some changes and see that it's actually working at tens of thousands, many tens of thousands. What we'd want to do is test it thoroughly and see if there's any corner cases where it has a problem, and then work on fixing those. And this is on our list to do. We will absolutely do this. And this won't take all that long till we do it, but it's not at the top of our list. And the reason is because current usage is 1% of what we already are doing. We're only at 1%. We're only using 1% of our current throttle. So there's not a whole lot of pressure to move the throttle up today. I do think we're going to get to the point, maybe not all that far from now, when we do need to raise the throttle, and then we'll raise it a lot. But right now, our top priority is getting new features out and making the system work in a lot of really cool ways that we keep announcing. We had HCS and then HTS, and now we have other things we're working on. This is what our top priority is. We do have on the to-do list, make the throttle even better than 100 times current usage, but it's not the very top priority because it's 100 times current usage.
All right. Thank you, Leemon. Mance, a few weeks ago, I chatted with Rob at FTPOS, and he said, everyone will be using Hedera without knowing it. Can you clarify how this will happen in concrete terms and how it is expected to result in more awareness of Hedera at scale?
Yeah. So I touched on this just a moment ago. What we've created is the equivalent of a distributed hosted operating system. When you today visit an application through your web browser, you can't tell what the operating system is that the application is running on top of on some server somewhere. It's all of that is under the hood. it's opaque to you as the user. You just interact with the web app. That's the same is going to be true for us. So if you look at the coupon bureau, for example, and you go and you use a coupon at Target, and that coupon gets scanned through the point of sale system, well, there's a lot that's going on under the hood that will end up using our infrastructure as well as the coupon bureau's infrastructure, and the person using the coupon doesn't see any of that. Or you get a vaccine in the UK, through the NHS. The delivery and infrastructure that makes it possible for you to receive that vaccine in part uses our technology. That's completely opaque to the end user. And that's going to be true increasingly. What we see are ecosystems of users that have a common interest in a given application or use case deploying on top of Hedera. And in most cases, the end users, they don't see what's going on under the hood. That's what Rob was talking about. That's what I was talking about in an interview with Rob as well in a recent conference. But that's what we mean when we say it'll be transparent to the end users.
All right, thank you, Mance. Leemon, if the security of one shard is compromised, is it possible to firewall the others by monitoring cross-shard communications and catching any contradictions in state proofs that are shared between them?
Oh, great question. And I just remembered you said sharding. Your previous question asked about sharding as well. So I should have talked about that too. So I'll answer them both right here. Perfect. Sharding is a cool thing. We're doing this, we will be doing this. Other ledgers are doing it. And sharding gives you really high throughput. So, I said many tens of thousands. That was for a single shard. For unlimited shards, you have unlimited throughput. I mean, you really can. You can do 1 million transactions a second if you have enough shards. You can do 1 billion transactions a second if you have enough shards. You can do 1 trillion transactions a second if you have enough shards. Now, it only works if the transaction patterns are the right kind. So what you would have to do is say, well, if our transactions end up getting spread out well across all the shards, then there is no limit. You could do, a quadrillion transactions per second if you had a quadrillion shards to do it, and each one's only being given 1 transaction a second. However, if all of your transactions are going to one account, transferring to one account, and you don't have a replica of that account in other shards or sub-accounts of it in other shards, then of course, shards don't help at all. They run at the speed of a single shard. Sharding didn't help. And so what we would expect is that the real world is a mixture of both kinds, and that you would take some steps, like if it's a really popular account, you'd sort of have sub-accounts in several other shards to kind of spread out the work. There's various tricks you can do. And so what you would expect is that sharding is incredibly useful. We will absolutely be able to do more than 1 million a second when we have shards. If you have enough shards, you have any speed you want. And I do expect that access patterns would be such that you could actually get in the real world more than 1 million a second with us. And that's true. There will also be cases where the access patterns really do need to have a single shard be fast. And in those cases, we really will be fast. So that's this answer to the speed. The answer for the security is fascinating. And this is true for any system that does sharding, except we're a little bit better in some ways. The whole point of sharding is that you don't keep the whole history of everything in every shard. The whole point was to divide up your effort. And so for a given account, if it's stored in this shard, Alice has an account in this shard, and Bob has an account in this shard, what you have to do is have this, when Alice wants to transfer to Bob, this shard has to send a message to this shard saying, we have officially approved this transaction. She has enough in the account, the transaction is valid, we are now deducting that from her account. Would you please add it to Bob's? This shard over here can't actually see what the balance is in Alice's account. It isn't actually visible. And so this one is going to have to just take this shard's word for it that Alice did have that much in her account, and it has been properly deducted, and her balance has now gone down the proper amount. That's all this shard can do. And so this shard then will increment Bob's. Now what this shard can verify is that that message that said, hey, please increment Bob's because we've already decremented Alice's, that message is a perfectly valid message from this shard, digitally signed by more than 2/3 or more than 1/3 or whatever of the people in this shard. You have to say, if it has been digitally signed by a bunch of people over here, then we will believe it. So in a single shard network, you need to have more than 2/3 of your nodes being honest and active. In a sharded network, you need to have more than 2/3 of the nodes in each shard being honest and active. If they all shut down, then the shard shuts down, or if too many of them shut down, then the shard shuts down. That only freezes that one shard, which just means, well, we can't send or receive to Alice, but everybody can still do things otherwise. So Bob and Carol can still send coins back and forth. It's just Alice that's kind of frozen. So that's good. If a shard freezes, that's okay. However, if a shard is corrupted, then you could just, counterfeit HBARs out of nothing, or counterfeit tokens, or lie about what a smart contract did. I mean, you could do anything. And this is true for any sharded system. This is even true for systems that have bridges between them, where the bridge is a bunch of validators. If you can corrupt them all, in some cases, if you don't have the equivalent of a state proof or cryptographic proofs, you'd have problems. And so the bottom line is that sharding is ABFT. It is actually super secure for Hedera, as long as each shard has more than 2/3 honest. And so we'll have various mechanisms for doing that. We can talk about that more in the future. We're not doing sharding today, but we'll do it, and it will give you, more than 1 million a second. Sure, if you have enough shards, it'll be any number you can think of, and it really will happen. But we will have ABFT. The entire sharded system will be asynchronous Byzantine fault tolerant, because we have state proofs and finality, and you have to have those two things. And each shard is ABFT. That's how you get the whole thing being ABFT. And so the sharding system will be very good, but you have to make sure that each shard is secure. Oh, and then what if you aren't even worried about, what if you aren't sure about that even? There is one last thing you can do, which is even better. Don't use a shard, use an AppNet. This is the Hedera consensus service. You can do all your processing in an AppNet. You get enormous speedups and greater privacy, and it allows all the kinds of firewalling that was asked in this question. This question really is not asking about sharding, it's asking about AppNets. And so with an AppNet, you're totally secure. And if more than 2/3 of the AppNet isn't honest, if everybody in the AppNet is dishonest, every single person, that's okay. That just means that whatever was stored in the AppNet is compromised, but the network as a whole, the Hedera network, isn't hurt at all. So you're much safer from the AppNet. The AppNet can't do any harm, as opposed to a shard that could do harm. And you have greater privacy, and you can even set up the AppNet where, if you don't trust the people in the AppNet, you run one of the nodes, and so you're guaranteed to have security. There's lots of cool things you can do with AppNets. They can be much better than shards for some things. But for other things, sharding is good, and we'll do that too.
Right. Thank you, Leemon. Mance, the next one for you, Hedera has mentioned Unibright as a partner in the new HTS ecosystem. Can you give a little bit more color on the nature of this relationship?
Yeah, sure. So Unibright is an enterprise blockchain business integrator, and they will be integrating their Unibright Frequency platform with HTS, the Hedera token service, to scale asset tokenization and decentralized finance activities for enterprise adoption. We're also working closely with them in the context of the baseline protocol, and more information will be shared in the coming months.
All right, thanks, Mance. Leemon, okay. I know you've talked about this before. It's gotten some attention. If quantum technology develops along the lines those involved hope it will, do you think it is more likely there will be a synergistic relationship between it and Hedera's technology, or will Hedera's DLT and others take a back seat to the quantum internet?
Oh, wow. There are so many misconceptions about the quantum internet. That's just insane. So the quantum internet, I don't even know how much I want to go into right now. It's a big subject. We're very short on time. The quantum internet is cool when it comes to sensors, not when it comes to computers. Let me just say that. So the quantum internet is allowed to transfer not data, but not information, but quantum information. It's a different kind of thing. And what it really should not be thought of is like an internet. The quantum internet is not an internet. It's not like connecting two quantum computers. What it really is a way to turn two quantum computers that are far apart into a single quantum computer. That's what the quantum internet would do. And for building a quantum computer, well, it's easier to put them all in the same room. So why would you split it across states and slow it down and make it harder to do? Just put it in the same room. So just to combine these two to make a single quantum computer to do computation doesn't make any sense. For sensors, though, you can do amazing things. And there are some really magic things you can do in quantum mechanics with sensors, including I can see you by deciding whether or not to bounce light off of you. And even if I don't bounce a single photon off of you, I can still see you. Yeah, that's quantum weirdness. The fact that I flipped a coin and could have bounced some light off of you lets me see you, even though I didn't actually do it. And there have been real world demonstrations of this and of other things. And a quantum internet could actually connect widely separated satellites and make them act as one. There's just amazing things you can do with the quantum internet. So that would be a complement to Hedera. It would not be a replacement for Hedera or for ledgers, and it would not really be part of Hedera or ledgers. We're all about information, not quantum information. So it would just be something really cool. It's like saying, well, if we get self-driving cars, what will the effect of that be on Hedera? Well, there's no real effect, but the people using it could store data on Hedera, and same thing with this. You know, the really cool things that your new sensors discover could be stored on Hedera. Then there's also the question about, could quantum computers hurt Hedera and other ledgers? And the truth is the whole industry will just switch to different algorithms that aren't hurt. It's not a big deal. It's like a Y2K. There's some coding you have to do and it slows you down a little bit. I hate that, but it's not a big deal. So that's the short answer. I would love to talk a really long time about quantum stuff. There's just really weird stuff that's going on right now that perhaps you haven't even heard of. That's really cool. Be fun to talk about.
We may have to do a whole session on quantum computing. Okay, Mance, central banks, are the rumors true? Are they looking at Hedera?
So this is going to be short as well. We now have council members that care deeply about CBDCs. That's all I'm going to say.
All right. We are getting to the top of the hour, so I appreciate those. We're trying to get through as many as we can. Leemon, has it been decided how nodes will be split between shards yet? Will there be specialty shards where a node has to meet specific criteria for things like gaming versus things like file storage? Any insights?
No. So because any compromised shard will compromise the whole network, they all have to be about the same. And so what we will end up having is that people will be randomly assigned to shards, will be randomly shuffled between shards. The shards will all be basically interchangeable, because you can't say, well, we're going to firewall this shard and be safe if that shard is compromised. You can't do that by the nature of shards. If you want that ability, use AppNets, use HCS, beautiful system. But if you really want shards, I mean, as they're traditionally defined, then you have to randomize it all and have them all be the same. You can't have a shard just for one country. You can't have a shard just for one application. You can't have a shard just for one kind of thing. They have to be kind of interchangeable.
All right. Mance, we have a community member who was surprised to see it cost 1 HBAR to withdraw HBARs from one of the exchanges. Is this a standard transaction fee? And how will the transaction costs develop in the future?
Yeah, when it comes to the pricing of exchanges, we have no insight into how they choose those numbers. It's not a standard transaction fee on the Hedera platform. The Hedera fee is 1/100th of a cent. For most transactions, it's tiny. So I don't know where that number comes from. It has nothing to do with us.
All right. Leemon, is Hashgraph more limited by bandwidth or hardware?
Probably bandwidth. It depends on whether you care about throughput or latency, but probably bandwidth. But you know, it keeps going back and forth because we keep improving it. So you improve it, now it's hardware limited. So then you improve this, and now it's bandwidth limited. And you improve this, now it's hardware limited, and just keep improving it. So yeah, it's hard to say, but probably bandwidth.
All right. Mance, for our developers out there, what is the process of getting help from Hedera to build a dApp on HTS?
Yeah, the first thing you should do is join the Discord channel. All of our DAs, our developer advocates, are members of that channel. They're super responsive. Go to hedera.com/discord to get a pointer, but that's the first step.
All right. And that channel has been posted in the chat as well. And then Leemon, when the network is permissionless, what kind of compute specs will be required to run a node? And will we have some, step-by-step instructions for setting one up so that more people can participate?
Sure. So the instructions, specs are, think a gaming computer, but without the GPU. Actually, at the moment, we're not using GPUs. We wrote really good code to verify signatures on the GPU, but we're fast enough without it. We can run, as I said, tens of thousands a second without it. So who knows? But maybe we would require a GPU. But right now, it'd be like a gaming computer without the GPU, but with a faster hard drive. It needs to be an SSD and a really fast one. Yeah, that's kind of the specs that we're currently using. Oh, and will it be easy to set up? Yeah, really, really easy. Because the nodes, to be able to automatically update themselves, have to kind of automate all the effort of updating, of setting themselves up. And so what you do is you set up a tiny, tiny bit, and then it just sets itself up all the rest of the way. And so that's kind of critical to the whole system working. And so it becomes really easy to add a new computer to the system. You just basically install Docker and install one or two other things and you're done.
All right. Well, thank you both. The hour has flown by. I know we didn't get to all of the questions. We will try to answer as many of them next month as we can. Again, happy Earth Week to everyone, to our community around the globe. We hope you will take a look at some of the resources for how Hedera is energy efficient, as well as be inspired by some of the applications that are building on us, trying to make our planet a better place, a more healthy place. And thank you, everyone. Have a great weekend.
Thanks.
Thank you. See you in a month.